All right. This video is going to address how to multiply and divide, essentially, really just division, um, fractions and or other numbers. And we're also going to talk a little bit about the properties of division or the rules of division. Again, it doesn't have as many properties as multiplication. A lot of the things like commutativity, you can't switch the order of the numbers. You know, something like 1 divided by 2 is not the same as 2 divided by 1. So again, a lot of those properties don't work. But again, we still need to be able to operate or do the operation of division. One thing that does kind of hold true are the rules of division as far as negatives go. Multiplication, as we know, positive times positive meant positives. Well, same thing goes for division. Positive and a negative mixed. Again, if we're dividing either a negative, like this -4 divided by 5 over here, or by a positive, or down on the bottom here, we got a couple of negatives. Again, negative negative is going to make positive. And again, any mix of positive and negative is going to be negative. If you have an odd number of negatives, again, that's a great way to think of it, you're going to end up negative. So if we looked at the problems over here at the right, very quickly, I can already tell you that first division problem is going to come out negative. Notice we have 2 negatives going on here. So again, this one's going to come up positive. And on the bottom, again, 1 negative, 1 positive. So again, it's going to be a negative answer. So very simply, those rules kind of hold true, which is very helpful. The other things we know about division, dividing is sort of the same thing as multiplying by the reciprocal. So that's going to help us out over here on the right when we talk about these problems. -4/5, right? -4/5 divided by 2/15 is really the same thing as -4/5. Notice we didn't change that first fraction, multiplied by 15/2. We're going to take that second fraction, and again, we're going to find its reciprocal. Basically flip it over. The numerator becomes the denominator becomes the numerator, and now we can go ahead and complete that problem. Now, there are ways to sort of reduce as we go, but we're going to take this the simple way. I'm just going to remind us, multiplying fractions, we multiply what's on the top, and we multiply what's on the bottom. So again, 5 times 2 would be 10, and -4 times 15 would be -60. And then finally, -60 divided by 10 will actually get to that division. Well, the nice part again, when we know we've got those zeros on the ends, we know 10 goes into both of these, so -60 divided by 10 will just be -6. In that same way, on the next problem, again, on the next one, we got -26 divided by a -1/3, right? And -26 divided by a -1/3. So the first thing I'm going to remember, and notice in this purple oval down here, is that any number can be written as a fraction, right? Any whole number or any integer can be written as a fraction. So -26, being an integer, is really -26/1. But again, notice I didn't change the number. That would be equal to -26. But when I went from division, right, this big fraction bar, to multiplication, I did have to take that denominator, and we found its reciprocal. We flipped that 3 to the top, we left the 1 on the bottom, and it doesn't really matter where the negative goes, because as we know again, negative times negative is going to end up positive. So 26 times 3 over 1, right, 1 times 1 would have been 1, so we didn't really need the denominator, is going to come out to 78. Then finally down here on the bottom, let's go ahead and complete this one, kind of in those same lines. Again, what if I want to divide a fraction by a whole number? Well, the best thing that I can do, right, is actually make that 3, oops, and it doesn't want to let me write here. Give me 1 second. There we go. Get that 3 divided by 1. So again, we're going to take that second fraction though, and we're going to find its reciprocal. So -x/12, right? Doesn't matter if we put the negative on top, bottom, or out in front, multiplied by the reciprocal of 3/1, or basically 1/3. Then we multiply across, so -x times 1 will be -x, and 12 times 3 will be 36. A couple of the quick rules just to remember. If we have a 0 on top of a fraction, right, 0 divided by any number, much like multiplying by 0, 0 divided by any number is 0, right? We have 0 A's, or 0 halves, 0 tenths, 0 whatever it might be, right? However, if we flip that over, its reciprocal then, the reciprocal of 0, would be a divided by 0, and we can never divide by 0. How many times does 0 go into something? Well, it really doesn't, right? If you multiply by 0, you get 0. If you divide by 0, it's undefined, we say. We use that word in a very specific spots. So again, make sure you use that. A divided by 0 is undefined, right? Undefined. All right. So just a couple more examples for you. How can division and kind of that distributive property be mixed? Well, notice on the top here, we've got a 10x minus 25, two non-like terms. I can't subtract those, but they're both being divided by 5 right now. And that's the easy way to think of it. If I'm thinking about that distributive property, I'm dividing both the 5 into the 10 as well as the 5 into the 25, which means if I kind of take that and move it over here, I'm going to divide 10x by 5, but I'm also going to divide 25 by 5. And notice I've got that subtraction in between, just like it was in the numerator. I'm just sort of separating into two fractions. And now we can say, well, hey, a number times a variable divided by a number, I can divide into that coefficient, right? That number with the variable. 10x divided by 5 would just be 2x. And of course, 25 divided by 5 would be 5. But notice we get, again, two non-like terms, so we're just going to get an answer of 2x minus 5. One other thing that we can do to apply division fairly simply, and just a good reminder for us, is when we talk about the mean or the average of two numbers or three numbers, or right down here, 4 numbers. The mean, again, is adding up the set of numbers, then dividing by how many numbers there were, dividing by the quantity, right, or what we get, by how many numbers there were. Well, since we have 4 numbers, the first thing we're going to say is negative 34 plus 11 plus 0 plus 3 divided by 4. Now, that 0 is important. It doesn't really matter to the addition, because as we know, negative 34 plus 11 is negative 23. Plus 3 is going to be negative 20. Plus 0 is still negative 20. However, the fact that that 0 is there means we're dividing by 4. If we just eliminate the 0 because we didn't think it mattered, we would only divide by 3. We'd get a very different answer. So again, those 4 numbers, including 0 here, divided by 4. And so again, negative 20 divided by 4 is negative 5. Just an easy application of division, one of the places in the real world where we use division a lot. Okay. So I hope that helps you with division. Again, if you have any questions, make sure you talk to your teacher. Otherwise, have a great day.